Ah, goodness gracious. Well, it wouldn't be a live stream if there wasn't some monumental screw up on day one. But this is why we do it. All right. Yeah, the reason was I was getting signal on here, but there was no. Sorry, this button wasn't on. Okay, so mic level looks pretty good. There is music in the background, but it doesn't seem too loud, so I think we're okay. Okay, so so yeah, I mean, most of this was reading and setting up, so that's not too bad. What I want to do now is take this input and I want to split it up into the various arrays. So I'm going to take the input and I'm going to split this on a new line. That's going to give me 2 parts. Not 2 parts. This is going to give me lines. And then lines, I want to split. And then I want this to have max splits. I think I can do that. Split that. Returns the longest possible subsequence of the collection in order that doesn't contain elements. Okay. That's actually pretty good. Yeah, so this one is going to be split on new lines. And then this one is going to split with this one. We're going to do max splits where separator. This is going to be max splits is 2, and where the separator, which is going to be some sort of string subsequence, is empty. I want to know if that is all white space. Is white space. Okay, so then this one is going to give me my my 2 column numbers, and I need to do that for each one. So this is going to be, oh yeah, that's not going to work because I still need to iterate. So this is going to be 4 line and lines. I'm going to have a left list is an array of ints, and the right list is also an array of ints. For each one, we're going to take the line and we're going to split it. Yeah, and I want to do this one. I want to do max splits 2, where separator, and I get the character in, and I think I could just do this where separator dot is white space. Nice. Okay, so that gives us our pair of numbers, and if we take a look at the type here, this is a string subsequence. So we're going to say left list dot append. We're going to cast it to an integer, and then this one will be right list dot append pair 1. Okay, so at this point now we should just be able to print out left is this one and right is this one. We're just going to return an empty string for now. Okay, let's rerun the test, and so we can see the output in the console. That is mighty small. Let's make this a little bit bigger. Still pretty small. Okay, so we have 34133. Sorry, 342133. 342133, and then the right one 435393. Okay, so those are correct. So now I need to sort these arrays when we're done. And then I'm going to pop off the numbers of each one. So we can do left list.sort, right list.sort, and then we can take the left list, we can or we can zip the two. So we'll take left list and right list, and we're going to get our nums in that list. And then these are going to contain two different ones. So we're going to have a running sum, which will be 0, and then the difference is going to be the difference between the two. And I don't know, did it say anything about absolute? It's probably just the absolute difference between the numbers. So I'm going to say nums 0 minus nums 1. Okay. This will be actually nums.0, nums.1, because it's a tuple. And then sum is going to plus equal the diff. And so if I run that, then I can run this and return the sum. And let's run the test again. And the test succeeded. So we got 11. There is definitely going to be a more functional way of doing this thing, where we could probably take, and this is more for just for fun. I don't necessarily think this is better because this is really easy to read. But we could take our lines and then map each line to its pair, and I'm just going to return a tuple this time. So this time we're going to do an int of pair 0 and an int of pair 1. So that'll return a tuple. Now I have an array of tuples, and I want to that needs to be returned. This is one thing I like about Rust, is that the type inlays end up helping a lot. And in Swift, you kind of have to just assign it to something and then see what the return type is. So you can see that I've got an array of tuples, and I want those array of tuples to be collected into these two lists. So that's where we're going to use reduce. And we need to reduce that into two different arrays here. So maybe I say let lists, or rather var lists is a tuple of two arrays of ints, and they both start out empty. Then I can reduce into the lists, and we've got our partial results and then our pair. And then we can say lists.0.append pair.0 and lists.1.append pair.1. So that gives me now X becomes an array. Instead of an array of tuples, it's now a tuple of two arrays. Then I want to map that to sort the two. So lists in, and yep, we're going to create a new tuple with the two sorted, and then then we're ready to do the differences of the two. So now we're going to, this is going to be mapped into an array of differences for each one. So each one here is going to give us our pair, and then we're going to do pair.0 minus pair.1 and take the absolute value. That's true. This one doesn't have any map function, so I think that I just have to move this up into here. So now I have my... oh no, that is what I want. Let me think. Yeah, I guess this isn't really a helpful structure anymore for them to still be in this order. I think I want a flat map here and return the zip sequence. And I can't flat map because this can't, let's see. Yeah, inlay hints would really help here. Let me go back to this because I know what we had here. We have a tuple of two arrays that are added here, and then I want once those are all done. The strange thing is I would like to map here, but I can't because the map gives me the result gives me this type. I think what I can do here is say let lists equals this, then just take this type here and put it into here. So it starts off as an array there. Mutating list is a let constant. Yeah, this becomes partial result. That's why. Partial result. Okay. Now I have the two lists, and I can zip the lists. Lists.0 and lists.1. That's going to give me my pair. And we'll take the absolute value of the difference minus pair.1. And then I can reduce that with 0 and plus to do the sum. I think that was an interesting exercise. Let's see if that actually works. It thinks that these are any's, so I need to do something like this to force it into be an int array. Yeah. Okay, let's run the test again. And the test failed this time. I got 13. Let's see. That's pretty strange. Let me make sure that my lists are correct. They are not correct. Oh, I didn't sort them. That's why. These need to be sorted. Okay, test succeeded. Let's go back over to the challenge. Okay. To find the total distance in the right, blah, blah, blah. Your actual distance may contain what is the total distance between your things. Oh, I need to actually log in. And I think I did GitHub before. I'm pretty sure I did. Okay. To begin, get your puzzle input. So I'm going to take that. And this is going to be my... this is going to be my puzzle input that I'm going to put inside of my sources here. New empty file, new from clipboard. This will be input. All these numbers look small enough to fit in an int, so that's good. And then over in package.swift, I'm not sure, I may need to set this up as a resource. Let's see what it does first. So down here, I'm going to say let input equals, and this is going to be bundle.main. URL for resource with extension. We'll do input text. And then that's going to be data, contents of oh, I need to import Foundation for that. Contents of URL. And then we'll do, that needs to be a string with data. That data encoding is .utf8. This one needs a try. And then we can pass input here. And that needs to be force unwrapped. Okay. Now when I run it, it's going to run with this input. Let's see if it actually works. Yeah, I can't find that. So let's take a look real quick at resources here. Resources. Yeah, here we go. So inside of our target, we're going to do this. Resources process input.text. There we go. So this will end up being a lot of copy paste for each day, I think. Resources process, that takes a comma. Name dependencies resources. There we go. Okay, still can't find that. let's see. Oh yeah, we also don't want this. We want bundle.module. I don't know if that matters in this case. It does. Okay. So our sum is 1579939, and let's go check that against the real answer. Okay, continue to part 2. Your analysis only confirmed what everyone feared. The two lists of location IDs are very different. Or are they? The historians can't agree on which group made mistakes or how to read most of the chief's handwriting, but in the commotion you notice an interesting detail. A lot of location IDs appear in both lists. Maybe the other numbers aren't location IDs at all, but rather misinterpreted handwriting. This time you'll need to figure out exactly how often each number from the left list appears in the right list. Calculate a total similarity score by adding up each number in the left list after multiplying it by the number of times that number appears in the right list. Adding up each number in the left list after multiplying by the number of times it appears in the right list. Okay. Here are the sample lists again. For the sample list, the first number on the list is 3. It appears in the right list 3 times, so it's 9. Okay. So let's jump over to our test again. So this is going to be test part 1. One nice thing about Swift testing is you don't need to prefix every method with test, which I like a lot. Okay, so this one is going to do part 2, and the expected answer we get should be 31. Okay, let's go over here and add a part 2. Func part 2 returns a string. This also needs to take its input. Okay, so part 2 is going to be very similar to part 1. We're going to do, it's basically the sum part. Let's see. I think what we're going to do here is instead of having these lists be an array of tuples like that, and we don't need to sort them anymore either, so this is going to be slightly different. I'm going to take the... This may look a little weird, but let's say I have a structure with the numbers. I'm going to do a struct instead of this tuple. We'll call it container, and this is going to have a var for the number list, which will start off as an empty array, and then a number lookup, which is going to be a dictionary of int to int. And then when we're processing each one, so this gives me 2 numbers, and now we're going to reduce it into that container type. So now on the our partial result dot oh wait, I need to create an instance of this, not just the type. Okay, so we're going to append the pair.0 to the list, but then we're going to look at the number lookup for pair.1, and we're going to, we need to check to see if it exists already. I don't know if there's an easy way to do this with the dictionary. So if the partial result, and I'm just going to call this container because it'll be easier. Container. If the container dot number lookup for that pair.1 is nil, then we need to initialize it to 0. Then when we're done, we can say container number lookup pair.1 plus equals 1. And then that one needs to be this, and I think I can do it in place like this. So now we have list.0. Well, that doesn't even work anymore. We're going to, let's just get rid of dot list. This one is container. Container.list. We're going to map that to its number. That's going to be number times the container number lookup for that number. And if it exists, if it doesn't exist, then this should be 0. And I think there's also, I believe, a default. Yeah, we can do that. And I wonder if I could do this default 0 plus equals 1. That's actually a lot nicer. Okay, so then when we have all those numbers, then we're going to reduce this with 0 and plus like we did before. Let's move these to their own lines. And now we return sum. So we're going to run. Did we run both of them? Yeah, okay, so part 2 worked. So now let's run. Let's print. I don't want to print the lists anymore because that's noisy. We're going to print day 1, part 1. And then I'm going to do the same thing, but with the separator. Day 1, part 2. Okay, and we'll run it. And we get this number. Let's go plop it in. Okay, so that's day 1 done. Pretty easy. Had some streaming issues, but other than that, yeah. Let me know what you think about this this series. Last year I think I made it to day 13 or 14, and it became real work and took me a lot of time, and that's time that I don't really have. So we'll see how far we get. I'm definitely not going to finish it this year, especially if it's at all any more difficult than last year, because I like the challenge and I like sort of mob programming and live streaming and stuff like that. It's pretty fun. But once it starts to feel like work and it gets frustrating and it eats up a lot of your time, it becomes less fun. So I hope you join me for the ride, and I will see you tomorrow for day 2.